Now students, let us see the example 4.2. As last time I have read it. Find the magnitude and direction of resultant of two vectors, vector A and vector B, but in terms of their magnitudes and angle theta. So here two vectors are there. We have to determine its resultant vector, which is capital R, but we have to determine the formula of magnitude of this resultant vector R in terms of magnitude of vector A and magnitude of vector B. Thereafter, let this vector R makes an angle equal to alpha with respect to vector A. Then we have to determine the equation of alpha, and that is also in terms of the magnitude of vector A and vector B. So here, as you can see, we are taking the two different vectors. One is vector A, another is vector B. They are making an angle equal to theta. Vector OP equal to vector A. Vector OQ equal to vector B. Then by method of parallelogram, so you complete the parallelogram by drawing a one line from the head of the vector B, QS parallel to vector A, drawing another line from the head of the vector P, PS parallel to vector B. These two lines are intersecting at a point S. So by joining this origin O with S, we get diagonal of parallelogram OPSQ, and that diagonal representing as the resultant vector R. So as you can see, vector OP equal to A, vector OQ equal to B, and theta is the angle between vector A and vector B. Using the method of parallelogram, we get vector OS equal to vector R as the resultant vector. So from diagram you can see this is one vector, from its head this is another vector. So this vector PS being parallel to vector B, you can write here vector OQ equal to vector PS equal to vector B. So resulting vector OS equal to sum of two vector, one is vector OP plus another vector PS, but PS is equivalent to OQ. So resultant vector OS equal to OP plus OQ, vector OP plus vector OQ, and it is equal to what? OP is replaced by A, OQ is replaced by B, to vector R equal to vector A plus B. Now we have to determine the magnitude of this vector R. To find the magnitude of this vector R, now we draw a one more line SN, which is perpendicular to the extended line OP. So to find the magnitude of vector R, draw a line SN perpendicular, or you can say normal, to the extended line OP. So when you draw like this one, then you will get, this is a right angle triangle PNS, where angle N is 90 degree, and at the same time you draw from the point P another perpendicular line to the diagonal OS. So PN is perpendicular to OS. So for triangle PSN, this triangle PSN, angle theta, because these two lines are parallel, as this is the angle theta, this angle should also be equal to theta. So for triangle PSN, we get PN. What is PN? The PN is adjacent side of the right angle triangle, and SN is opposite side to the angle theta. For adjacent side, it is always hypotenuse into cos theta, and for opposite side, it is hypotenuse into sin theta. So for triangle PSN, we get PN equal to magnitude of vector B into cos theta, or you can write simply B cos theta, and SN is equal to magnitude of vector B into sin theta, or you can write SN equal to B sin theta. We have to make the use of this. Now you consider the right angle triangle SON. For this right angle triangle SON, this OS is hypotenuse, and as you know, according to Pythagoras theorem, square of hypotenuse. So for triangle SON, OS square is equal to sum of the squares of adjacent side and perpendicular and opposite side. So OS square equal to ON square plus SN square. But ON, what is ON? So this distance ON is equal to sum of two distances. One is OP, another is PN. Where OP is magnitude of vector OP equal to magnitude of A equal to simply A. And PN is equal to, we are saying it is B cos theta. So ON equal to OP plus PN equal to A plus B cos theta. So we get OS square equal to ON square plus SN square, where ON is replaced by A plus B cos theta. SN is replaced by B sin theta. So A plus B cos theta whole square plus B sin theta square. So it is A square plus 2AB cos theta plus B square cos square theta plus B square sin square theta. Here B square is common. In bracket cos square theta plus sin square theta. And you know its value is 1. So we get OS square. OS is representing resultant vector R magnitude. The magnitude of vector R square is equal to A square plus twice AB cos theta plus B square. So simply R equal to square root of A square plus B square plus twice AB cos theta. And this is the formula of resultant of the magnitude of the resultant vector of any two vectors which are making an angle theta in between them. Thereafter, now we remember this formula is also be known as the law of cosines, and here you have to use this formula too many times whenever you are going to be solving some numericals. Then we have to find out the angle alpha, that is to find the direction, that is the angle alpha of vector R. Now we will consider the triangle OSN and triangle PSN. So one big triangle OSN, and another is triangle PSN, where SN is common side. And for this common side, how much be the value for such two different triangle? So for triangle OSN, SN, as you can see, SN is opposite side to the angle alpha. You can say it is equal to what? Hypotenuse into sine. So we can write Sn is equal to hypotenuse value is OS into sine alpha. OS is equal to what? Magnitude of resultant vector R into sine alpha. And for triangle PSN, this much small triangle, again Sn is opposite to the angle theta. That's why it is equal to what? Magnitude of hypotenuse, that is vector B ka magnitude into sine of the angle. So Sn is equal to your B sine theta. But this Sn being same, you can say this R sine alpha equal to B sine theta. So thus R sine alpha equal to B sine theta. This implies one important formula. R upon sine theta equal to B upon sine alpha. B, remember, here this PS is vector B and PS is vector B. And opposite to this side PS, which one angle? It is alpha. So here magnitude of vector B upon the sine of the angle alpha which is in front of it. So B upon sine alpha is equal to hypotenuse, or you can say resultant magnitude vector R upon sine theta. So thus B, remember, in such kind of the diagram where vector R is the resultant vector of two vectors and theta is the angle between these two vectors, then magnitude of this vector R upon sine theta equal to the magnitude of this vector B upon sine alpha. तो वेक्टर B यानी कि PS के सामने ये अल्फा है, वो खास ध्यान रखना। कौन सी साइड के सामने, कौन सा एंगल है, तो वो साइड अपॉन साइन ऑफ दैट एंगल। तो यहाँ पे अल्फा है, तो क्या है मिलेगा? साइन ऑफ अल्फा। सो R sin theta equal to B sin alpha, and this formula you remember. From this we can write therefore sin alpha की equation. So sin alpha equal to what? You will get B upon R into sin theta. So this is important formula to determine the angle alpha. So sin alpha equal to magnitude of this vector B upon magnitude of resultant vector R into sin theta. Another formula to determine the angle alpha. Now again you consider the right angle triangle SON. Triangle SON. For this triangle SON, this angle is alpha. So you determine the tangent alpha. Tangent alpha will be equal to opposite side SN upon adjacent side ON. So tangent alpha is equal to Sn upon On. But On is equal to sum of two values. One is OP, another is Pn. OP plus Pn. OP is magnitude of vector A and Pn is B cos theta and Sn is B for this right angle triangle PSN. This Sn is B cos theta. So we can write tangent alpha is equal to B sin theta upon A plus B cos theta. So this is another formula to determine the angle alpha. So there are two formulas, equation 2 and equation 3, to determine the direction of resultant vector R of the two vectors, vector A and vector B. Now for the remaining part of the same numerical, so here I have drawn that little diagram again. So this was vector OS equal to resultant vector R. This vector OP equal to vector A. And this is PS is the vector B. PM was perpendicular to OS. So M is making an angle 90 degree. So now here we are having two triangles. One triangle OPM, another triangle SPM. For these two triangles we get the value of PM. So SPM is normal to OS. For triangle OPM, PM. So what is PM? PM is again opposite to the angle alpha. That's why you can write here this angle is 90 degree. That's why OM will become what? So just in opposite to the 90 degree, this will become hypotenuse. So OP will be hypotenuse. And here PS will be hypotenuse. So here you can write this PM is equal to what? It is equal to hypotenuse into sin alpha. That means OP into sin alpha. But OP is equal to what? Magnitude of vector A. Therefore PM is equal to A sin alpha. And for right angle triangle SPM, again this PS will be hypotenuse. And magnitude of PS will be equal to magnitude of B. Here is the angle beta. And you can see this PM is in front of the angle beta. That's why you can write PM is equal to hypotenuse into sin beta. But hypotenuse is vector, magnitude of vector B. So PM is equal to B into sin beta. So thus we are having two values of one length PM. One is A sin alpha, another is B sin beta. But both being same, you can write A sin alpha equal to B sin beta. So again you can write A upon sin beta इक्वल टू बी अपॉन साइन अल्फा. मतलब क्या कि ये जो साइड है उसके सामने का जो एंगल वो साइन के साथ लेने का उसका रेशियो. तो मैग्नीट्यूड ऑफ वेक्टर ए अपॉन साइन बीटा. एंड यहाँ पे अल्फा के सामने कौन सा है? यहाँ पे बीटा, सॉरी वेक्टर बी इज है. तो मैग्नीट्यूड ऑफ बी अपॉन साइन अल्फा. तो ए अपॉन साइन बीटा इक्वल टू बी अपॉन साइन अल्फा. तो ए अपॉन साइन बीटा इक्वल टू बी अपॉन साइन अल्फा. तो बी रिमेंबर this formula also. They use earlier formula. According to earlier formula, we have seen that b upon sin alpha equal to what there? What say? R upon sin theta. So combining these two from equation 1 and 4, so we can write one common equation a upon sin beta. यानी कि जो साइड है उसके सामने का एंगल, यहाँ पे बी साइड के सामने का एंगल इसके साथ लेने का साइन के साथ. तो a upon sin beta and b upon sin alpha. तो a upon sin beta equal to b upon sin alpha equal to क्या था? हाइपोटेनियस r एंड उसका मैग्नीट्यूड r, और वो कौन सा एंगल बनाता था? sin थीटा बनाता था. दैट्स व्हाई इट इज r upon sin theta. तो be remember this is a important formula and it is also be known as the law of sines. Thereafter we see the next example, and this next example is 4.3. I read that example. You have to see in your textbook on the page number 72. On the page number 72, a motorboat is racing towards the north at a speed of 25 km per hour, and water current. What is the meaning of water current? Water current, that means the speed of flowing water. speed of flowing water. The water current flows at a speed of how much? 10 km per hour in the direction of 60 degree east of south. तो 60 डिग्री ईस्ट ऑफ साउथ का मतलब क्या? 60 डिग्री ईस्ट ऑफ साउथ, साउथ से ईस्ट की डायरेक्शन में 60 डिग्री बनाता हुआ, साउथ से ईस्ट की ओर कितना एंगल? 60 डिग्री बनाता हुआ. इट कैन बी रीड एज ईस्ट ऑफ साउथ. तो 60 डिग्री ईस्ट ऑफ साउथ. एंड देन यू हैव टू फाइंड आउट द रिजल्टेंट वेलोसिटी ऑफ दिस मोटर बॉट. The resultant velocity of motor boat is how much? So here you must have a knowledge of 4 directions. So as you can see, this is north, this is south, this is east, this is west. But actually here you have to, instead of considering this in vertical plane, you have to take it in horizontal plane. Then you can understand it very well. So here you can consider this is north, sorry, this is east, this is west. This is north, this is south. The water boat is in which direction? It is going in this direction with the speed of how much? 25 km per hour at the same time. And you consider this is the water, this is the one river, and this river having a water current. Water current in which direction? Not exactly east direction, but it is in the direction of making 60 degree from south to east. So this is south, this is east. Is it clear? This is east, this is south. तो आपको क्या करना है? इस साउथ से ईस्ट की ओर कितना एंगल? 60 डिग्री बनाता हुआ, like this one. तो this is the actual flow of water. The flow of water is like this one, and motor boat is going like this one. So what will happen here? This flow of water which will drag the motor boat, because of which instead of traveling in straight direction, it will slightly bend, and finally it moves in such a direction, and that direction will be the resultant velocity of motor boat, and that you can see now from this diagram. So here in north direction, the water boat is moving with the speed of vector v. At the same time, this is the water current, and this water current is making an angle equal to how much? 60 degree from south towards east. So it can be read as 60 degree east of south. So this is vector VC. And now you can see between vector VC and vector VB, the angle is more than 90 degree. How much? You know, this total angle will be 180 degree, out of which you subtract 60. This kind of the angle theta will be what? 180 minus 60 will be equal to 120. So now you are having a common point O, from which you are having the two vectors, one vector VB, another vector VC. And then by using the method of parallelogram, you draw a one line from the point P, is parallel to vector VB. You draw another line from the vector Q, parallel to vector VC. They are cutting at a one point C. So now you are getting a one parallelogram OPSQ. By joining this origin of two common vectors with point S, you will get diagonal, and this diagonal will represent the resultant vector. So I am going to be joining, and it is like this one. So one can see this is the resultant vector, and let this resultant vector is making somewhat angle is phi, and that phi will be what? The direction of resultant velocity with respect to this north direction, or you can say this direction is from north to east. As it is from north to east, it can be read as east of north. It can be read as east of north, and this east of north angle is how much? That we have to find. So now we have to determine the two things. One is magnitude of resultant vector R, and another is angle phi. So by using this geometry, let us see. Let vector VB and vector VC are the velocities of motor boat and water current. So angle between these two vectors, vector VC and vector VB, is 120 degree is the angle. Now complete the parallelogram. Then this vector OR is equal to vector VB plus VC is the resultant velocity of the motor body. Then magnitude of this resultant velocity is equal to square root of क्या होगा according to earlier law cosines, एक का स्क्वायर दूसरे का स्क्वायर प्लस ट्वाइस ऑफ एक का वैल्यू दूसरे का वैल्यू इनटू cos ऑफ ये कर बिटवीन है तो VB स्क्वायर प्लस VC स्क्वायर प्लस ट्वाइस VB VC cos theta. Substituting the value, VB is 25, VC is 10, 2 into 25 into 10 into cos of 120. So this is 625 plus 100 plus this is 25 into 10, 250 into 2, 500 into cos 20 value is minus 1 by 2. So this is 625 plus 100, 725, 500 upon 2, 250 but negative sign, so minus 250, answer is square root of 475. And 475 has the value square root of 475, 21.8. So magnitude of resultant velocity is 28 meter, 21.8 kilometer per hour. So motor body will move in this direction with resultant velocity of 21.8 kilometer per hour. So here it is in which direction? So it is in direction making an angle alpha with respect to this north side. So here that angle we have to find. So we have to use the formula as we have seen earlier. So there what was the formula? जो resultant vector है वो vector का magnitude upon the sine of the angle between the two original vectors. That means r upon sin theta equal of VC के सामने ये angle phi है इसलिए क्या आएगा VC का magnitude upon sin of the phi. So you can write here according to law of sines. According to the law of sines, r upon sin theta equal to VC upon sin phi. Therefore, sin phi equal to VC upon r into sin theta. So VC value is 10, r value is 21.8, sin 120 is there. Therefore, sin phi is equal to 10 upon 21.8 into sin 60. Sin 120 is equivalent to sin 60. According to trigonometry, sin pi minus theta is equal to the sin theta. So here, sin 120 can be written as 180 minus 60. 180 minus 60. So sin 120 and sin 180 minus 60 will becoming equal to what sin 60. According to this equation, instead of theta, there will be 60 to sin 60. Then substituting value of sin 60 is root 3 by 2. So 10 into root 3 by 2 upon 21.8. 10 upon 2 is 5. 5 into root 3 upon 21.8. And we remember value of root 3 is 1.732. Value of square root of 2 is 1.414. Value of root 3 is 1.732. Substituting, you will get sin phi is equal to 0.9397. Therefore, phi equal to sin inverse of 0.397. And from natural sine, you may get according to this value the angle. So this phi is equal to 23.4 degree. In which direction? East of north. That means from north towards east, making an angle of 23.4 degree. Okay.